The other thing is that the object was relatively big objects from outside the solar system, and that was puzzling.
There's dark energy responsible for the accelerated expansion of the universe?
What if humanity's first true planetary defense crisis doesn't unfold on Earth, but on Mars? At 2:47 a.m. Eastern Time, the Monte Carlo simulation running on Harvard's supercomputers stops generating probability fans. Graduate student Maya Chen stares at her screen as thousands of trajectory possibilities collapse into a single, terrifying cone. The uncertainty ellipse that once sprawled across millions of kilometers has shrunk to a crimson sliver barely wider than Mars itself. She calls her advisor, then NASA, then everyone. The interstellar Comet 3I Atlas isn't wandering anymore. It's navigating. Hour by hour, the crisis escalates through carefully choreographed protocols. At hour 3, Harvard's draft press release circulates through encrypted Slack channels. Interstellar object shows anomalous trajectory modifications. By hour 9, JPL confirms what Harvard hoped was computational error. Each 17-minute pulse registers as a velocity change detectable across 47 million kilometers of space. At hour 12, JPL Director Dr. Michael Chen authorizes immediate escalation to the Planetary Defense Coordination Office. PDCO's escalation categories exist for moments like this. Level 1 means tracking. Level 2 adds international coordination. Level 3 triggers active defense planning. 3I Atlas jumps directly to Level 3. By hour 18, encrypted video calls connect Washington to Brussels to Moscow to Beijing. At the 24-hour mark, the 5 Sigma confidence zone places 3I Atlas on a direct collision course with Mars. Probability of impact reaches 73% and rising. This is how humanity discovers it's about to witness the first interstellar bombardment in recorded history. 10 billion tons of material from another star system blazes across space at nearly 90 kilometers per second. But 3I Atlas shouldn't be blazing at all. At 4 astronomical units from the Sun, where solar energy barely whispers across the void, the comet erupts with activity that rewrites physics textbooks. A coma stretches 100,000 kilometers across space, fed by gas production rates that rival objects passing Mercury's orbit. Surface temperatures reach 200 Kelvin, despite receiving 16 times less solar energy than Earth. Every 17 minutes, like cosmic clockwork, jets of gas burst from specific points on the nucleus. Each pulse generates 1 gigawatt of power, enough to run a city, steering the object with thrust vectors that would challenge human spacecraft. The James Webb Space Telescope captures chemical fingerprints that exist in no database. Metallic iron and platinum scatter through the coma, alongside deuterium concentrations 50 times higher than any solar system object. The isotope signatures tell impossible stories. Formation temperatures below -220 Celsius, mixed with elements forged in stellar furnaces exceeding 1,000 degrees. This isn't just an unusual comet. This is matter that carries the contradictory chemistry of multiple cosmic environments, somehow fused into a single entity that navigates between stars. At NASA's Center for Near-Earth Object Studies, screens display probability visualizations that tell an increasingly terrifying story. The Monte Carlo ensemble starts as a fan-shaped spray of trajectories, thousands of possible paths spreading across millions of kilometers. Each new observation narrows the fan. Yellow probability zones shift to orange, then red. Dr. Elena Vasquez watches the uncertainty ellipse shrink pixel by pixel. The 3 Sigma zone glows green on her monitor, extending 50,000 kilometers from Mars' surface. Still safe. The 4 Sigma zone shifts to yellow at 30,000 kilometers. Concerning but manageable. The 5 Sigma zone blazes orange at 15,000 kilometers. The 6 Sigma zone pulses red, meaning direct impact. the danger tail of the probability distribution clings to Mars like a cosmic noose. Analysts in the room stop their conversations as the latest batch of observations shifts the central estimate deeper into the orange zone. Someone mutters, "The tail's not shrinking anymore. It's the whole distribution." Each observation refines the covariance matrix, the mathematical foundation that describes uncertainty in position and velocity. Traditional objects show random scatter in their residuals, small deviations that average out over time. 3i Atlas demonstrates systematic deviations, purposeful corrections that defeat the averaging process. Vasquez runs the collision models that keep her awake at night. Impact velocity would reach 90 kilometers per second. Kinetic energy would equal 4.05 times 10 to the 23rd power joules, equivalent to 97 billion megatons of TNT. The numbers transform from academic calculations into scenarios that could reshape a planet. History provides context for humanity's first interstellar bombardment. The Tunguska event of 1908 flattened 2,000 square kilometers of Siberian forest. The Chelyabinsk meteor of 2013 injured over 1,000 people. These events shaped modern planetary defense philosophy, but every protocol assumes Earth-crossing objects following predictable trajectories. 3i Atlas operates outside these assumptions. The PDCO's measured escalation doctrine breaks down when confronted with phenomena that transcend natural celestial mechanics. Response planning requires predictable physics and adequate preparation time. None apply to an interstellar navigator demonstrating apparent intelligence. The harsh reality emerges during classified briefings. Planetary defense ends at Earth's orbit. Mars operates beyond the protective umbrella of detection networks, deflection systems, and response protocols designed for terrestrial survival. NASA's DART mission proved humanity can alter asteroid trajectories through kinetic impact, but DART required years of planning, precise positioning, and a target following predictable physics. 3i Atlas arrives with 47 days' notice, navigates independently of gravitational forces, and approaches from interstellar space where no human technology operates. ESA's proposed Hera mission could theoretically reach Mars orbit, but requires launch windows that won't open for months. Private industry offers no immediate solutions. International cooperation fractures along predictable lines as governments grapple with unprecedented threat assessment. UN Security Council emergency sessions convene behind closed doors, delegates speaking in carefully measured language about anomalous interplanetary phenomena requiring coordinated response. The term anomalous appears in every official statement, as if bureaucratic language could contain cosmic mystery within familiar categories. Encrypted video calls connect Washington to Brussels to Moscow to Beijing at all hours. NASA shares trajectory data while withholding propulsion analysis, claiming ongoing review of observational methods. ESA contributes tracking resources while privately questioning American interpretations of navigation capabilities. Roscosmos provides computational support, but disputes any suggestions of artificial guidance systems. China's National Space Administration offers deep space tracking assistance through carefully worded diplomatic channels, emphasizing scientific cooperation in the face of natural phenomena. ISRO contributes Mars orbiter mission data while maintaining strategic distance from Western response coordination. Each agency pursues independent analysis while participating in multinational coordination protocols. Behind public cooperation, governments task military space commands with classified assessments. Intelligence services investigate whether the object represents natural phenomena beyond current understanding or evidence of non-terrestrial technology. The implications cascade through defense establishments worldwide as analysts attempt to categorize a threat that transcends existing classification systems. Draft treaties circulate through diplomatic channels, establishing frameworks for information sharing and coordinated response to future interstellar objects. The documents carefully avoid speculating about artificial origins while creating legal structures that could accommodate contact with non-terrestrial intelligence. Private aerospace companies receive briefings that reshape entire development programs. SpaceX quietly evaluates Mars mission delays and spacecraft vulnerability assessments. Lockheed Martin reviews satellite constellation protection against high-velocity debris. Blue Origin analyzes potential market impacts of interplanetary collision events. Public response diverges dramatically from institutional caution as mainstream media coverage ranges from scientific skepticism to wild speculation. CNN broadcasts hourly updates featuring graphics that show the shrinking probability zones like a countdown clock. BBC Science presents interviews with astronomers who struggle to explain navigation capabilities in cosmic debris while maintaining professional credibility. Fox News panels debate whether the object represents alien reconnaissance, divine intervention, or elaborate hoax. Polling data reveals a public more willing to embrace extraordinary explanations than the scientific establishment. 67% believe 3I Atlas demonstrates artificial intelligence. 43% consider it evidence of extraterrestrial technology. 29% view the Mars encounter as cosmic protection for Earth. 18% expect the object to change course before impact, suggesting divine or alien intervention. The cosmic bodyguard theory dominates social media discourse. Mars serves as Earth's shield, attracting interstellar threats away from inhabited worlds. This anthropocentric interpretation comforts populations unwilling to accept random cosmic violence, while elevating Mars from dead planet to heroic protector. Talk shows invite astronomers who find themselves defending conventional physics against hosts, convinced that steering comets prove alien visitation. Late-night comedians joke about Mars taking one for the team, while internet memes depict the red planet as a cosmic superhero. Economic markets respond with characteristic volatility as space-related stocks fluctuate on daily news updates about impact probability. Social media hashtags Mars Defender and Alien Navigator accumulate millions of posts within hours. YouTube videos titled "The Comet That Steers Itself" generate tens of millions of views as content creators explain orbital mechanics to audiences hungry for extraordinary explanations. TikTok creators develop elaborate theories about interstellar navigation while NASA struggles to maintain scientific credibility. Religious leaders grapple with theological implications of intelligence operating on cosmic scales. Some interpret the event as divine protection for Earth, others as test of human faith in scientific understanding. New Age communities embrace the arrival as spiritual awakening, while skeptical organizations organize campaigns to promote scientific literacy in the face of exotic claims. Impact simulations paint scenarios that transform Mars from humanity's future second home into a cautionary tale about cosmic violence. The collision would excavate a crater 400 kilometers across, penetrating deep into the planet's mantle and ejecting material at velocities exceeding escape velocity. The impact would release energy equivalent to every nuclear weapon on Earth detonated simultaneously, concentrated into seconds. Atmospheric modeling predicts consequences extending far beyond the initial explosion. Global dust storms would persist for years, raising surface temperatures through greenhouse effects while simultaneously blocking solar radiation. The thin Martian atmosphere, already a fragile envelope barely capable of supporting surface pressure, faces catastrophic loss as impact shockwaves propagate around the planet. The debris field would create a temporary ring system around Mars, millions of fragments orbiting at various altitudes and inclinations. This cosmic debris cloud would persist for decades, making orbital operations extremely hazardous. Any spacecraft attempting to reach Mars would face bombardment from impact ejecta traveling at hypervelocity. Every robotic explorer currently operating on Mars would face destruction. NASA's Perseverance rover, collecting samples in Jezero crater, would vanish in the global catastrophe. The Ingenuity helicopter, humanity's first powered aircraft on another planet, would be swept away by shock waves circling the globe multiple times. ESA's Trace Gas Orbiter and China's Zhurong rover represent billions of dollars in scientific infrastructure that would be reduced to debris scattered across a transformed landscape. Material ejected at escape velocity could threaten Earth's satellite constellations months after impact. Particles traveling at interplanetary velocities would create hazardous space weather extending throughout the inner solar system. GPS navigation satellites, communication networks, and the International Space Station would face bombardment from fragments launched by an interstellar collision 47 million kilometers away. The psychological impact on human space exploration would prove equally devastating. Mars represents humanity's next great leap, the stepping stone to becoming a multiplanetary species. An interstellar bombardment would transform the red planet from a symbol of human potential into a reminder that cosmic violence operates on scales beyond terrestrial comprehension. As the countdown continues, humanity confronts questions that transcend immediate crisis management. If 3I Atlas represents natural phenomena, then cosmic mechanics operate by principles that make current physics seem elementary. If it demonstrates artificial intelligence, then consciousness transcends biological origins and operates on scales beyond terrestrial imagination. The timing raises additional mysteries. Why does this interstellar navigator arrive precisely when human technology can detect and analyze its properties? Each 17-minute pulse brings new questions about intention and capability. Natural processes don't navigate with surgical precision towards specific planetary targets. 23 days remain. The uncertainty ellipse measures less than Mars's diameter. Every observation confirms what mathematical models predict. Impact probability now exceeds 89%, with margins of error that shrink towards statistical certainty. International space agencies coordinate observational resources while privately preparing for aftermath scenarios. Mars orbits toward its appointment with an interstellar visitor that operates by rules transcending natural cosmic mechanics. Whether the encounter represents first contact with cosmic intelligence or education about physics beyond current understanding, the collision will mark humanity's transition from cosmic isolation to cosmic awareness. In 23 days, an object from beyond our solar system will demonstrate whether intelligence exists only on planets or navigates between stars with intentions that transform random cosmic events into deliberate actions. The countdown continues. Each pulse brings answers that will reshape human understanding of our place among stars that may harbor intelligence capable of crossing the void with precision that makes interstellar space a highway rather than an obstacle to cosmic communication.